I'm Professor Brad Fulton, and welcome to my Stats podcast. This is an edited audio recording of my course. Each lecture is its own episode, and there's a total of 24 lectures. This course provides an introduction to the quantitative methods social scientists and data analysts use to collect and evaluate empirical data about society. Through this course, you will learn to gather, describe, and analyze data with an emphasis on the application and interpretation of these methods. This course will also help you to be a more informed and critical reader of academic research, public opinion polling, and advertisement claims that present statistical evidence. Although some of the current events I reference might be dated, the content is timeless. I hope you enjoy this lecture, and if you have any questions, you can email me at bradrfulton@gmail.com. Hi, my name is Professor Fulton. If you like this podcast, you'll love the book I use for the course. It's titled Statistics, Unlocking the Power of Data. This book uses a highly intuitive approach to help students visualize statistical concepts, which accelerates understanding. I've reviewed dozens of textbooks, and Unlocking the Power of Data is hands down the best one out there, mainly because of its unique intuitive approach and straightforward explanations. You can find a link to the textbook in the show notes, and if you use the promo code BLOCK5, you'll get a 10% discount. For this class, it's going to be doing a lot of just troubleshooting, but I think this is valuable because you're actually doing the research and you're confronting the problems that will naturally come up, and so I'd rather address them in class together because you're probably having overlapping questions. So feel free to come with questions, little specific things, or even if you can't find variables or whatever, that's part of the process. The thing I want to start with is by pulling way back to talk about the scientific method. And this relates to the theory section that you guys are developing. And I noticed a common theme that I think would be helpful to address. We do this not just in the natural sciences, but also in the social sciences. The process for the scientific method is theory-based. So the first step in the process is forming a theory to explain a social phenomena. You're an observer of society and you notice a particular phenomena. So the phenomenon could be that married people are more happy than unmarried people. And that's just an observation that you make. And so you want to form a theory that explains the social phenomena. So the theory is not married people are more happy. That's just a description of a social reality or even a speculation. But a theory would explain why married people tend to be more happy. And so when I'm asking you for a theory, it's not sort of describing a social phenomena, but it's more explaining why that social phenomena exists. Either you come up with a theory, or what I'm asking you guys to do is in journal articles, find theories that are sort of being thrown out there. And almost for every social phenomena, you'll find a theory that explains it in one direction, and then there's another theory out there that might say, no, actually people who are not married are more happy. And there'll be a theory to explain why that's the case or why we'd expect that type of finding. And so then as the researcher, you come up with a hypothesis. And a hypothesis, it's a testable hypothesis based on your theory. The process is saying, here's this theory out here that explains why married people are more happy. And so then you construct a hypothesis that says people who are married will tend to score higher on the happy scale. And so you're going to test this theory. And so the hypothesis is a very specific statement that is based on your theory. And then you test it. And so you test the hypothesis using data. We're using the GSS, and we have specific variables that we can use or that we have access to. And then after we do our hypothesis test, we assess the strength of evidence for or against the hypothesis. So this is the big picture process that we're going through. But I think a part where we're getting stuck is identifying the theory. Because just to say, I believe married people are happier than unmarried people, isn't really doing scientific research. It's an op-ed piece or some opinion that you have. Whereas we want to do more rigorous research, talk about marriage and happiness specifically. So this is from one of the articles that someone sent me, making a claim that married people are more happy, but in the description the student put married people are more happy. And what I really want, and this is in the article, is this theory. It says social causation theory contends that marriage increases happiness by providing emotional and financial support. These in turn buffer against the travails of life and preserve or increase happiness. If you look in the article, this is the theory that's driving their research. It isn't just, well, I'm married and I'm happy, so I think everyone else should be happy. It's more, there's actually things going on within the marriage contract that actually cause greater happiness. And so for each of your articles, particularly the academic articles, if you look within the first couple pages, you'll find the theory. But not all of them do. Some of them are just purely descriptive, and especially like Gallup poll or Pew Research or any of these sort of big research groups, they just more describe outcomes, which is what you saw. And if you ask the question, well, why are religious people more this or that, they typically don't go into that. They just say, this is what is. If you're pulling from an academic article or a book, you'll be able to find the theory that they're using. You have to dig a little, but it's in there. And it's basically asking the question of why or explaining, or you'll see the word theory that's in there. And so it's a matter of pulling that out. So the hypothesis then takes this theory and puts it into a testable form. And the hypothesis can be very simply stated. Being married is positively associated with happiness. Actually, the simpler the better, because you want it to be a very focused thing that you're testing. In general, especially since we have like 5 hypotheses that we're doing, it's best to start with your independent variable here on the first part, and then your dependent variable as the second part. What you're interested in is the relationship of your independent variable and its effect on your dependent variable. And so just for consistency, it's easiest to kind of read through, because we're not talking about happiness leading to marriage. Like, happy people tend to get married more. That's just a different research question. And so you want to keep your independent variable first as far as structuring your hypothesis. So then to test this hypothesis, we're using the GSS data to see if being married has a significant positive effect on a person's happiness. Again, we're starting with big theory, and then we sort of distill it down into a one-sentence hypothesis that we can test. There's other hypotheses that you could draw from this theory. Like, if you were studying financial well-being, you could say that marriage leads to greater financial stability. And so you could look at like income and marriage and things like that. So there isn't one hypothesis that comes with a theory. And then the last part is inference. Use the results of the hypothesis test to decide whether the data provides strong enough evidence to support the hypothesis or theory. So you're basically taking on this theory and either giving evidence for it or against it. And the hypothesis is linked to that theory. And if there's enough failed hypotheses, then we basically conclude this theory isn't really a very good theory. It doesn't actually explain the social world in the way that we'd expect it. So when I'm asking for theory, what I want to know is why you chose the independent variables that you chose. And it's based on theory that's out there. I kind of covered the sociological theory. A theory not only describes the relationship, but provides an explanation for the relationship. There's good theory and bad theory. So provide the citation of the article as well as a link to the PDF. Some of you just gave me the link, which was actually good, because then I could just go and look at it and have a sense of what the article is. If it's just the citation, it's harder for me to actually find it, and then I can't really help you if you're getting stuck. So I was able to get the marriage and happiness one because the link was provided. And so then there's 2 types of articles that you'll tend to come across. One is a journalistic or descriptive, and that's like the Gallup poll, the Pew Research, things in the newspaper, where they're more journalistic in nature and they're describing a phenomena, whereas then there's academic or scholarly articles that are scientific or theory-based. You want to avoid these because you're going to struggle to find good theory in there, and more so focus on the scientific or theory-based. So any type of academic journal will give you the scientific or theory-based. So then evidence, this is another thing that kind of came up, that evidence in and of itself is not a theory. if someone says we have a lot of evidence that says that people who have a lot of money are happier or are happy in general or whatever, you might have a ton of data that says that, but that still is not a theory. The theory would explain why income is related to happiness. So evidence can be used to build a theory when one doesn't exist, or in the case of what we're doing, evidence can be used to test a theory that has been proposed. So the role of evidence is not to sort of, this is my theory, here's the evidence. It's more evidence is used to test a particular theory. So again, if you think of marriage and happiness, there's a specific theory out there, and we're using evidence, which is the GSS data, to test that theory. The last thing I was going to cover with this is hypothesis construction. This is the formula for it. A change in the independent variable is associated with a positive or negative change in the dependent variable. So you kind of want to have each of these components. So the change could be like an increase in age is positively associated with happiness score, or whatever it is that your dependent variable is. But you want to identify the direction of the change versus saying it's just associated or it's correlated. You want to say it's positively or negatively correlated. So this is kind of a tricky one that you guys are probably seeing, is that hypotheses need to be specific and then tied to the data you have available. So I think I'll use the marriage and happiness example, where that theory is saying being married is related to being happier. And so you want to use a variable that looks at married people and not married people. Versus, I think the variable that's been used is divorce, like have you ever been divorced, which is, you can see it's tied to it, but that's not what the theory is saying. The theory is saying being married causes you to be happy. And so even the divorce question, it asks, have you ever been divorced? And the people that it's asking to, those people actually might still be married, but just they're in a second marriage or third marriage. And so as you're using your theory and forming your hypothesis, make sure that your data and your variable match the theory that you're testing. So your variables need to match the hypothesis. You can recode your variable to match the hypothesis. So again, if the theory is that black people are happier than white people, then you can just recode the race variable to just look at black people and white people and drop out the other people and stuff. So just make sure that there's a consistent flow from your theory to your hypothesis to the actual data that you're using. And then another one that came up is only use one independent variable per hypothesis. Some of you are getting elaborate where you're saying that a person's religion and race interact together to affect income. And that's a valid sort of hypothesis, but it's more complex than what you would want to take on, because then you have two moving parts. You have race moving and religion moving, and their combined effect on income. And for this project, it's much simpler if you just focus on one independent variable per hypothesis. To sort of tie it back to what we've been doing in class, you state the alternative hypothesis in your paper, what you're proposing as, this is what I'm going to test. And then you test the null hypothesis in your analysis. And this is what the analysis does. It's testing what's the likelihood of getting an outcome as extreme as what we got if the null hypothesis was true. So in your paper, you just need to state the alternative hypothesis, and you don't even need to call it alternative. You just say, my hypothesis is that married people are happier than non-married people. And then in your analysis, you're going to see if marriage has any effect on happiness, if the effect is greater than 0 or significantly different than 0. So this is covering what I'm expecting or wanting in the intro and theory section and in the hypothesis construction. Well, let's take examples. Can I take one of yours, McKay?
Job loss one, that was kind of confusing.
Okay, so explain it just briefly.
How likely are you to lose your job in the next year?
Mm-hmm.
And I was like, not likely, somewhat likely, and then like fairly likely, and then very likely.
Uh-huh.
And I was just comparing that to your general happiness. Remember you said that maybe I should recode it because it was in the opposite order?
Yeah.
But then yesterday when I was trying to do the correlation between the two, it was coming out negative and saying that as you got happier, you were more likely to lose your job.
Okay.
When I tried recoding it.
But then what that's saying is that the more likely you are to lose your job or to think you're going to lose your job, the happier you are?
When I recoded it, it was saying that. But when I left it normal,
Oh,
it was
okay.
saying you're happier when you're less likely to lose your job.
Okay. Yeah, another thing that I guess will be helpful as you guys are coding your variables and forming your hypotheses, it's always best to keep everything in the same direction. Mm-hmm. So if your thing is happiness, frame your hypotheses such that X increases happiness. So like marriage is associated with an increase in happiness. Job stability is associated with an increase in happiness. Versus saying, it just gets confusing if you say job instability is associated with a decrease in happiness. Then you get confused because on your figure you're going to have negative numbers and positive numbers, and it's nice to just kind of know positive always means we're moving towards greater happiness. That would just help you and help the reader. And you can frame your paper much easier. Like, what leads to greater happiness? It's having a stable job, being married, and versus like, well, this leads to greater happiness, but then this also leads to less happiness, and then your reader gets all confused because they're like, okay, wait, what are we talking about exactly? Same with like attitudes about homosexuality. Pick a frame. It's good that you guys are working through that. It makes for a clearer presentation and your reader can follow you. The beneficial thing is as you take advanced classes in sociology, this is what your papers will have to look like. You probably won't have to do data analysis, or actually you will if you do the senior thesis or things like that. But they'll have to be framed this way. What is your theory? What is the hypothesis that's being tested? And what are the outcomes? So this isn't just a stats thing.
Interesting one about the happiness and then the number of children you have.
Okay.
My question is, with the happiness variable, it seems like everything is mainly between like very happy and pretty happy.
Uh-huh.
Are you supposed to take just like what the higher number is, or because it seems like they're all in between, like
oh, you mean
whatever, like 1 and 2, or like
the outcome that you get?
Yeah. Like when I did age, it was just like very similar. Like I did 30 versus 50,
yeah.
And like one was like 1.3 versus like 1.5.
Uh-huh. So the happiness variable isn't the greatest variable because it's not very fine-grained.
Yeah.
Like you only have 3 options. But it's fine to use, and another way of thinking about it is in your mind, change the scale. Instead of 1 to 3, have it be 1 to 30.
Okay.
And so if they have a score of 2.5, that's 25 out of 30, which sounds a little, it's like, oh, okay, a 25 is different than a 21, versus what's the difference between 2.1 and 2.5?
Okay.
Don't worry about it, the numbers being so close to each other. But I will also say, like, Brittany's is interesting with homosexual attitudes. Like, she threw in a liberal person that thinks premarital sex is okay and all these things, and the person still ended up being opposed to homosexual activity.
I ran it again, and I picked like the most liberal categories. Because a lot of mine are like binary categories, so I didn't include it last night. But it was literally, I picked someone who had a graduate's degree who, the same things, like was liberal and then had no problem with premarital sex, and it was still like a 3.9. Like it still wasn't that they had no problem with it. It was still like sometimes wrong.
Yeah. So when I say like pick hypothetical people, it's actually most interesting if you pick people at the extremes, because then you can see some good variation. But with Brittany's example, what's your adjusted R-squared for?
It's 0.252.
Okay. Her R-squared for her final model is 0.252. And what that's saying is that her model explains 25% of the variation in attitudes about homosexuality. So what she's finding is, even with the variables that she has in there, it's not shifting attitudes nearly as much as she thinks. But what her model is missing is 75% of the explained variation. So in a sense, there's other variables out there that will really swing the attitudes about homosexuality or even happiness. Like you guys are looking at job loss and marriage and stuff, but you're probably only explaining 20% of the variation. And so what that's telling you is that you're missing key variables that really affect happiness. And don't worry about missing it, but it's just let you know that that's why you're not seeing big swings. But if you find the golden variable that really drives happiness, then you'll notice. And then that's what you write a paper on. You're like, wow, we find that number of children actually really affects happiness level. The things that we're going to cover today is how do you do multiple regression with categorical variables. And so up until this point, we've done quantitative variables and ordered categorical, which the ordered categorical we can kind of treat as quantitative because there's a trend in the values. But what do you do if you just have a nominal categorical variable or even a binary categorical variable? That's what we're going to talk about, how to include those into your model. We're going to start with binary categorical variables and how to interpret them. And so sex is a binary variable such that female equals 0 and male equals 1. And actually, I think I recoded it to be this way, because in the GSS it's 1 and 2, which makes it more confusing. So I recoded it so that if you're a female, you get a score of 0, and if you're a male, you get a score of 1. And that's sort of the template for a binary variable. It has 2 options, binary, and it's typically in the format of 0 and 1. And so if we look at a regression again, we have political views as our dependent variable. And if we look at the regression equation, it's going to be 4.088 plus 0.085 times sex. And if you look at this, well, you can see how I've recoded it, and I'll explain that more, but it's basically saying if the respondent has the characteristic of being male, it'll affect the political views increase the political views by 0.085. And so if you think about it in the sense of a binary variable is saying, do you have this characteristic or not? And so for male, female, it's kind of weird. You basically are saying you're either male or not male, and the not male is female. So the way you would set up the regression equation is like this, and if you wanted to look at specifics, if for sex equals 0 for a female, it'd be political views, multiply it out where you enter 0 for sex. And so that would be the mean political views score for females is 4.088. And then if the sex of the respondent was male, you would plug in 1. And then the outcome is 4.173. The way you interpret this is a 1 unit increase in the variable sex, i.e. going from female to male, corresponds with a 0.085 increase in political views. So again, we're still thinking in terms of a 1 unit increase, but it's moving from one category to the other category. And really, a way of thinking about this is for respondents who have this characteristic, this is how it's going to affect the dependent variable. That's binary categorical variables. Another name for them is called dummy variables. I should have looked up why they're called dummy variables. A dummy variable equals 1 if the case falls into the category represented by the dummy variable. So this dummy variable that we created is called male. And so if the case or the respondent is that, then it gets a value of 1. And if they're not that, then it gets a value of 0. So the category assigned to the value 0 is what's referred to as the reference category, and this will become clear as we build out to categorical variables that have more categories. But basically, the reference category is the category that's assigned the value 0. When you look at males, you're comparing them in reference to the reference category. So how much different are males to females in regards to political views and so on. So beta male is the effect that being male has on the dependent variable relative to the reference category of being female. So it's just a much more complicated way of saying we're comparing males to females, but it's a way to quantify it. So when we say it's a 0.085 increase in political views, it's saying that's the difference between being male and being not male. And so even like your binary ones, it's probably helpful to convert them into 0-1 variables, because when you do predicted probabilities, it's easier to put in a value of 1 or 0. So incorporating nominal categorical variables, and this is probably where a lot of you guys are at, is you have some nominal variables And you're like, well, how do I put them into the model? And some of you have probably tried to put religion into your model, and it'll actually give you a coefficient, and it'll tell you whether or not it's significant. But if you think of religion, you have Catholic people, Protestant people, Jewish people, other religion, and like in the variable is coded such that Catholic might equal 1, Protestant might equal 2, Jewish might equal 3, and other equals 4. And if you put that in the regression just like that, it's going to pretend like Catholic people are the lowest people of the religion category and other are the highest, and it's going to say, is there any type of correlation between going from Catholic to other? It just doesn't make sense. What you're wanting to do is look at, is this person Catholic or not? Is this person Protestant or not? Jewish or not? Or other? And so what we'll be doing is we'll convert a variable with k categories into k minus 1 dummy variables, with the kth category being the reference group. Anytime you have a nominal categorical variable, you're going to have k number of categories that they could be. So let's say with religion we have 4 categories. We're going to create 3 dummy variables for 3 of the categories, and then the last category is your reference category. If you want to do what Chelsea's doing, if she's most interested in Catholics and how Catholics differ from the rest of religions, you would make Catholic your reference category, because then you could see how all these other religions differ from being Catholic. And so your reference category is typically the category that you're most interested in analyzing, that you're thinking has the biggest effect. So if you want to know how white people differ from the rest of the population, you would put white person as the reference category, and so on. Okay, so nominal means name. It has multiple categories. Let's see, did you have any?
Work stat.
Okay, work stat.
Yeah.
What are the categories?
Working full-time, working part-time, temporarily not working, unemployed, laid off, retired, school, keeping house, and other.
Okay, good. And do you have that one too?
Works like I just changed it to employed and unemployed.
Yeah.
Perfect.
Yeah.
What did you do with the person who's in school?
I like to employed and unemployed.
Okay,
Sorry.
so you sort of drop the rest of the people from. That's a perfect way to do it. And so your hypothesis related to that variable is what?
If you're working full-time, you're more likely to have high levels of happiness.
Okay. How could you recode or manipulate that variable work stat to fit your hypothesis?
The same way.
Okay, yeah. So then what you're doing is you're converting it into a binary variable. In that case, you could say employed equals 1 and unemployed equals 0, so that people who are employed have an increase in happiness. So race is a 3 categorical variable. It's white, black, and other. And so this code here, race m:1, creates 2 dummy variables where black and other with white as the reference category. And again, this is in the description of the GSS. You know, we started with 1 variable called race, and when we did m:1 to create 2 dummy variables, it created a variable called black and a variable called other. And it's basically saying if the respondent is black, then its effect on political views will be a negative 0.349 decrease in political views. And that's relative to the reference category, so relative to white people. The political views of black people will be a decrease in 0.349, and then other, compared to white people, is negative 0.263. So what this doesn't allow us to do is how do black people differ from other people? We can sort of look at the coefficients, but both of these are how do they differ from the reference category. So if you're really interested in black people in the rest of the population, then you would have black be the reference category. With the dummy variables, it's kind of like a switch that you take each of the categories, and a person can only fall into one of the categories. So if the person is black, then it's turning that switch on to equal 1 for black people, and it turns every other switch off. So like other would be 0. And so you're just saying if they have this characteristic, then this is what the effect would be. But I think as far as interpreting, The tricky part is remembering that it's in comparison to the reference category. So that's where it's important to know, because if you just say being black results in a decrease of negative 0.349, what does that mean compared to what? Whereas like when we have quantitative variables, being 20 years old has a certain effect, but it's in reference to being 30 years old, being 40 years old, or so on. So being black compared to being white corresponds with a negative 0.349 change in the value of political views. And being other corresponds with a negative 0.263 change in the value of political views. And so then the way that the regression equation for this is you treat each of these as a variable. And this is the same for binary as well. The nominal expands it out because you have multiple variables. But so black becomes a variable, other becomes a variable, and they each have a coefficient associated with it. And then if I want to know the political views of white people, a white person has a score of 0 on black and also a score of 0 on other, and then the outcome would be 4.181. If we do political views of black people, on the black variable they have a score of 1, whereas on the other variable they have a score of 0. And then the same with other, they get a score of 1 on other and a score of 0 on black. And then the tricky thing is sometimes you'll want to give a score for 1 for black and a score for 1 for other. It's an invalid prediction because a characteristic of nominal categorical variables is that you can only fit into one. So with race or religion, there might be a variable called mix, where it's a mix of two different races, but that would be a separate category. So just make sure that you would know how you're setting up your regression equation to make predictions. Categories need to be mutually exclusive. A person cannot be both black and other, at least with this data. And then the last thing that is coming up, as you guys are dropping people, like with Chris and McKay, as you're saying, okay, I'm only going to look at employed and unemployed, a thing to be aware of is that you might get to a point where, say you only want to look at unemployed Jewish people living in the South. Your sample is going to be highly constrained, and you might only have 10 people, like valid cases, and so make sure you're not straining your sample so small that your degrees of freedom are dropping too low to where you can't do an analysis. But I think most of you are starting off with 50,000 cases, so there's a good chance that you won't get that. But I guess in your final report or project, you're going to have to put the N that you're working with, and that's the N of your final analysis. So like, Chris, do you have your full model in GSS?
Yeah, I have all these.
Does it say what your valid cases are for your largest model with the most?
Oh, you mean like the totals?
Yeah.
Like total valid cases, that's like all the one they use. It's 26,269.
Okay.
Valid cases 26,276.
Okay. So if a person is missing data on any one of your variables, say they didn't give a response to WorkStat, then they'll be dropped from your analysis. So the N that really matters is your final model where you put all the variables together. It's a matter of putting in, that would be your N, is whatever is in your final sample. Case has missing data for any of the independent variables, it will be removed from the regression analysis. If there's a lot of missing data, your sample could be greatly reduced. And as you build a model, keep an eye on the number of valid cases in your model. Another thing to keep in mind is there's sometimes reasons for missing data. So like, let's say the question about income, all the Asian people opted to not answer that question. And so you have tons of missing data on a specific group. That's going to affect your analysis, and you'd almost have to say, I can't do an analysis on Asian people and income because over 50% of the Asian respondents didn't answer this question. So for 50% of the people, we just simply don't know what their income is. And so that's something to be aware of. The next ones are variable selection, and this is sort of what you guys are in the process of doing right now is, well, what variables do we put in our final model? The p-value for an independent variable can be taken as a rough measure of how helpful that variable is to the model. If you had a variable you thought was going to be really significant, well, I'll think of like McKay's. If you're looking at the variable divorce, and you're like, oh, should I use the variable divorce or use the variable marital status or whatever? It's walking through this process of looking at which one is more significant, and you can prune insignificant variables from the model to say, I thought this one was going to be good, but this one actually seems to be better. And you can also look at the relationships between independent variables. And so if two variables are strongly associated, perhaps both are not necessary. So like if you're looking at religion and you have both religious affiliation and religious attendance, and they seem to be canceling each other out, you can remove one of those or keep it in. Okay, some ways of deciding whether or not a variable should be included. Does it improve the adjusted R-squared? Does it add explanatory value? Does it help you in explaining the dependent variable? Does it have a low p-value? Is it associated with the dependent variable by itself? Like, does it have a clear direct effect? And is it strongly associated with any other independent variables? If yes, then including both would be redundant. And the last one is confounding variables, which we talked about at the very beginning of the course. And it's basically you have two variables that are related to each other, but then there's a third variable that's associated with it. And that's where multiple regression comes in, where if you suspect there's a confounding variable that it could explain the relationship between your independent and dependent variable, multiple regression allows you to test for confounding variables. So before, we could just look at a relationship between two variables. With multiple regression, we can actually put that third variable, the confounding variable, into the model. And the thing that you would see is whether an independent variable is still significant even after including the potential confounding variable in the model. So like if there's a variable that's really affecting the outcome, if you put that variable in, your original independent variable is going to lose effectiveness. It's going to become insignificant because the real variable has been added to the model. That covers the things I wanted to address today. Are there any other specific questions? So even if it's highly specific, it's fine because you're probably not the only one. In fact, multiple people have emailed me saying I have questions. So, Brittany?
I had a question on, I had like a 10 as a variable, like how often the 10 releases. I wasn't sure if that was like ordered, but then I ended up recoding it, so it was just like once a month or more.
Okay. With the variables, a lot of times it provides more information than you really want. Mm-hmm. And so if you really think the threshold is if you attend at least once a month, then sort of collapse all of the people who attend once a month or more and compare them with people who attend less than once a month. And then in your write-up, you be explicit about like this variable is comparing people who attend greater than once a month with those who attend less than once a month. Okay. Tonight's assignment, you'll know everything you need to incorporate all of your variables into your model. And so practically tomorrow you should have your models finished. What we're going to do tomorrow in class is more of a workshop, looking at each other's models and even explaining, okay, this is my dependent variable, these are the independent variables, this is how I coded them, and this is where I'm still having a problem, or I was trying to figure out how to recode this variable. And so it's helping you guys to troubleshoot or critique each other's models. But that's what we'll be working through, troubleshooting those things.